This lecture, let's create this cool background parallax effect directly on our screen space canvas sprite renderer game objects. Let's get that set up. So if you take a peek at our screen space canvas, we have 1, 2, 3, 4 different sprite renderers directly rendering on our screen space canvas. So if we modify them and slightly move them separately, we're going to get that nice parallax background effect. So the first one is actually just this background sort of image. The second one is this backdrop of these big buildings. I don't think I want to move this one either. But if we slightly move number 3 and then slightly move number 4, just even slightly more, we can get that really cool effect. In our scripts folder, in our miscellaneous folder, let's create a new C# script to do that. And we'll just call that Parallax. And let's open that up in VS Code. So what are we going to need? Well, we're going to need a reference to our camera to see how much it's moving. So let's go ahead and grab a reference to that. We'll go ahead and call it main camera, and we'll grab that in awake. So underscore main camera equals camera.main. Next, we just want to set up some additional logic to get these moving on some sort of offset. So we're going to need to actually cache a reference to our starting position. So right here, let's create a private vector 2 called start pause for start position. And to make sure we can modify some sort of offset in the inspector, let's create a float to do that. So serialized field, we'll create a private float called parallax offset, and we'll set it to something small to begin with. So something like 0.1. Except we actually want to make sure that's a negative value because we want it to go in the opposite direction of our camera. So in start, we just want to set our start position equal to transform.position. We'll be attaching these separately to each individual object that we want to have that parallax effect, in our case, the 2 that we mentioned. Now, you might actually think you want to move this in update, but we actually do indeed want to do it on fixed update because our player is moving on fixed update and our camera is following our player. So fixed update, and then we just want to grab a new vector 2, and we want to find a new position that we can modify every frame on fixed update. So to do that, let's actually create a property to do so. So private vector 2, and we'll call it travel. Now, you could probably even do this as a method of some kind, but I'm going to do this as an expression-bodied property. All that really means is every single time we access this variable, it's going to do some additional logic for us in that property. So the syntax to set up an expression-bodied property is with this arrow syntax, and then we just want to return our camera.main.transform.position minus our start position. So all we need to do is cast that specifically as a vector 2. Now back down in fixed update, we can go ahead and take our start position, add to it a new vector 2, the x value being our travel.x value, times our parallax offset. And then for the y value, we can just plug in 0 since in our case, we don't want our y to move. Then we just want to update its position. So transform.position is equal to new vector 2. We might actually need to do that as a vector 3. We'll find out shortly. And then we just want to take in our new position dot x and our transform dot position dot y since we don't want to move it on the y value. All right, no compilation errors. Looks like we're good to go there. And I think we're set to go. Let's head back into Unity and rig that up. So as previously mentioned, we don't want to put it on 1 or 2. We just want to put it on 3 or 4. So I'll go ahead and drag my parallax class onto those 2 game objects. Except now I'm realizing I'm totally doing my math backwards. We actually want to make sure our parallax offset value is as close to 1 as possible to get it moving not so fast, and then we can actually do it in the positive direction. So I was doing my math totally backwards, ignore me. We actually want to set our parallax value in our third image to something like 0.9. That'll get it moving pretty slowly because it's close to 1. And then in number 4, let's just set it to something like 0.8, and that should give us pretty close to the effect we're looking for. Now, the reason we have it set up like that is because in our parallax script, when we times it by this parallax offset, we're just trying to achieve very close to our 1 value when we take our travel.x of our camera, and then we times it by our parallax offset value. Very nice. Let's go ahead and hit play and see what that looks like. I'm just going to go ahead and turn off my sound for now manually up here in the top right. And then when we move, perfect. We've got a nice little parallax effect on these background images. Very cool. All right, well done on this lecture. When you're ready to move forward and continue implementing some new features, we'll go ahead and do so on the next lecture. I'll see you there. This lecture, let's create some one-way platforms that our player can jump through from bottom to top, get stuck on the top like it normally would, and then also press the down key or the S key to go through it. To do that, let's actually create a platform just right here that we can use in our scene as an example to play with. So I'm going to go ahead and create an empty game object, and I'm going to call this a platform_medium, since we'll create a couple prefabs that we can use. And let's go find those sprites in our directory. So I'm just going to manually use this search bar, search for platform, and then find this platform sprites folder, and then we can use these two different sprites as needed. Now you can barely see it. We'll see if I can zoom in a little bit. Nope, not really. I think this one is the middle sprite, and then we can use tiles_7 for the edges of the platform. So here's what I mean. Let's just go ahead and drag that in. I'm just going to zero that out so it's exactly in the center. And then there we go. We have the start of our platform. We can actually use tiles7 to be the edges. So let's go ahead and do that. Let's have 2 in the center. So holding control, I'm just going to duplicate it and then snap it over. And then I'm actually just going to go ahead and do that 2 more times. But we'll change these edge platforms, so this one and this one, to be tiles_07 in our sprite. Now the one on the left looks good. Let's just change the one on the right, and we'll just flip it on its Y rotation 180 degrees, and voila. There we go. Let's go ahead and add a box collider 2D to get the normal effect that you would think a normal platform might. Bit of an oversight on my part. Your box collider 2D should most definitely be attached to your platform medium parent game object. I'll fix that shortly. Now, if we go ahead and stretch this platform to be equal to the sprite of our platform, that's great. Let's go ahead and do one more thing before we talk about how to actually make this a one-way platform. Let's also, to all 4 of these tiles, let's add a sprite mask, just like we did with the tile mask prefabs, but this one, since it's not a tile map, we're just going to put it directly on the component. So, great, all 4 of those. And then all we need to do is just make sure that each individual one has the right sprite mask. So for the 2 tiles in the middle, let's actually just rename that. I'm going to call it middle. We'll also call this one middle. And then this one down here, we'll call it right and left accordingly. Well, for the 2 in the middle, we just need to make sure the sprite is the same as the sprite in the sprite render, so that's tiles08. We'll just go ahead and click the sprite, and then we'll just search for it manually, so tiles08. We'll go ahead and do the same for the ones on the right and the left, so both of those highlighted at the same time. I'm just going to go ahead and change that sprite to tiles_07, just to make sure that the sprite mask matches the sprite renderer sprite. That way, just to double check, if we go into our splatter prefab, we can actually see we have that same sort of splatter effect that we would have on something like the tile map. Great. I'll go ahead and Control Z that out now that we know that's working. And now comes the real magic. So let's make sure that this is set to ground to make sure that we can jump off it as normal. We'll go ahead and change that yes to all children. But just as a very clear, easy example, even though we can all see what's happening, we can't jump through the bottom because, of course, it has that normal box collider. So if we go into our platform medium and we find where we put that box collider, oh boy, where did I put that box collider? We'll just go ahead and delete this box collider here. Let's go ahead and do that. We can actually just copy the component, and then we can remove component, make sure it's not on the left one. Okay, silly me. How did that happen? Let's go ahead and put it on the platform medium. I can go ahead and add component, and we will find the box collider 2D. Great. And then I think we can just right-click this and paste component values. Let's see if that worked. Almost. Not quite. Let's just go ahead and make sure that is lined up with the platform as expected. Now, on the platform medium where we have the box collider as intended, we can add another component, and we can add a platform effector 2D. All we need to do is make sure that this is ticked as use one way, and then make sure on our box collider 2D, we just want to click this used by effector. And just like that, I think if we enable our gizmos, yep, we can actually see that it's actually only going to allow us to land on it from the top side. And that's actually all we need to do. Now when we click play, if we blow up our game view just so we can see it, we can actually jump through that platform on the bottom, which I just think is super nifty. Bit of an issue, most platformers will actually let us hit the down key and then it will go through the platform. Well, for that, we're actually going to need to create a little bit of custom logic. So let's go create that script. In our Assets folder, Scripts folder, and let's just put it in our Miscellaneous folder, even though this is getting quite large. Let's right-click, Create, New C# script, and we'll call it One-Way Platform. And before we enter VS Code, let's just go ahead and throw this one-way platform on our platform_medium game object. And let's open that up in VS Code. So what do we want to do? We basically just want to go in and check our player input, and if we hit the down key, we just want to go through the platform, which basically means we're just going to have to disable our colliders for a short amount of time. Well, how do we want to set that up? We're probably going to need some sort of physics collision. So let's create a on collision enter 2D for when our player hits the platform, and an on collision exit 2D for when the player leaves the platform. So we just want to check and make sure that the other.gameObject is indeed the player controller. So other.gameObject.getComponent. We'll just use the player controller since we know that's attached. Then we want to do something. We'll go ahead and do the same for on collision exit. And what do we want to actually do when the player is hitting the platform? Well, let's just create some sort of private bool to let us know that the player is indeed on this specific monobehavior platform. So private bool, and we'll just call it player on platform. And we'll start it at false to begin with. This way we can basically detect if the player is on the platform, and we can detect the player input. So let's go ahead and create a private void called detect player input. And because this is on input, if we make sure we are creating it in a good way, we can just go ahead and fire this on update. And we'll make sure we're not firing it too often using our input and our bool properly. So detect player input, we'll call that on update. And in here, if the player is not on the platform, we just want to return. So if player is not on the platform, we'll just use the little exclamation mark for shorthanded, then we just want to return. Well, next, let's check to see if our player hit the down key, in our case, the S key. Well, how can we do that? If we actually go into our player controller, we just want to use this move input vector too, because we also know that it's actually keeping track of our down Y movement, even though I think up to this point we haven't actually used it at all. So let's go into that. So player controller dot instance dot move input dot Y, if that's less than 0, since we know it's going to return that sort of negative float value, well then we just want to do something. So what do we want to do? We want to disable the colliders either from this platform or from the player. Now, here's the problem. We can't really disable colliders entirely because they're also doing a bunch of other things. We just need to make sure that our physics colliders from our player to this specific platform ignore each other and nothing more. So we're not actually disabling them. We're just disabling the physics comparatively just between the ones that we want to check. Now let's also keep in mind our player controller, I think, has those two different collider 2Ds that we need to disable. So let's create this as an IE enumerator for a coroutine, just so we can make sure we're waiting some amount of float before we re-enable them. So let's create a private IE enumerator, and we'll call it disable platform collider routine. And let's create some sort of float up top to check how long we want to disable those colliders compared to each other. So private float, and we'll call it disable collider time. And I think something close to 1 should give us about the correct result. And then while we're up here, let's also grab the collider from specifically this one-way platform that's attached to this mono behavior. In other words, that specific collider. So let's just go ahead and grab that. We'll grab private collider 2D, and we'll just call it collider. And in awake, we'll go ahead and grab that collider. Collider equals get component. We know there's only ever going to be one. We know it's a box collider, so I guess we can grab that specifically. Box collider 2D. Down here, we need to get the colliders from the player. So let's go ahead and do that. Collider 2D. We'll go ahead and make sure that this is an array because we know there's more than one. We'll call it player colliders. And then we'll just go into our player controller, .instance.getComponents with an S at the end, and grab all the colliders on the player. So collider 2D. So now that we have both, we just need to disable them from one another. And the way that we can actually do this is using physics2d.ignore collision and then just set each individual one that we want to ignore. So for that, because we have more than one on our player, we want to use a for each loop. So we'll go into player colliders. We'll just call it player collider. And we know that it's a collider 2D, so we'll change var to collider 2D to be specific. Next, physics2d.ignore collision. And if we check, we just need to compare collider 1 to collider 2 and then change it to either true or false depending on if we want to ignore it or not. So in this case, we do. So we're going to go into the player collider compared to the box collider of this one-way platform and change it to true because we want it to be ignored. Next, we just want to basically re-enable them after we wait a second. So yield, return, new, wait 4 seconds, and disable collider time. Afterwards, we just want to do the exact opposite. So I'm just going to go ahead and copy paste this and do nothing more other than change that to false to re-enable ignore collision back to true so they collide with each other. And with that, I think we're all set to go. All we want to do is fire this coroutine right here if our player is on the platform and we're pressing down. So start coroutine, disable platform collider routine. I like it. All right. And then of course we do want to make sure we're changing this bool appropriately. So if our player is on the platform, in other words, we collided with it, player on platform is true. And when we leave the platform, we'll just change that to false. All right, we'll give that a nice once over. I think we're set to go. Let's go try that out back in Unity. All right, moment of truth. Let's hit play. Let's see if we can go through the platform. Yep, that looks good. Hit the down button and yes, we are set to go. We are able to now go through the platform as well. The only thing I'd like to do is probably just set up a couple prefabs to get a few platforms throughout our scene. So let's go ahead and do that. Assets, prefabs folder, and we'll throw this in environment. I think that makes sense. We'll go ahead and prefab this platform medium, and I'm just going to sprinkle in a few more here and there. Not going to really think about it too much. And then we'll create a large platform prefab as well. All we need to do for that is just unpack one completely. So prefab, I'm going to right click it and unpack completely. And we'll rename this platform to platform_large. And then I'm just simply going to make it a little bit bigger. So I'm just going to duplicate my middle one a few times. One there, and we'll just do like 4 in total. I think is probably about right. And then all we need to do is change this one to tiles_7. Yep, that looks good. We'll just go ahead and change that to left. I think we need to rename our other one to middle and then change that tile as well to tiles08. And then I'm also just going to give my sprite masks a quick once over. Tiles08. Great, that matches. Make sure this one on the left matches as well. 7. Make sure I don't forget that. Yep. And I think we're good to go there. We'll make sure I prefab the large one as well. And I'm just going to sprinkle a few of those throughout my scene as well. Once again, not really going to think about it too much. I'm not overly concerned with level design at the moment. And the last thing that I'm going to do is just organize my hierarchy a bit and then we'll move on. So environment, right click, create. I'm just going to go ahead and create a platforms parent game object. And we'll throw all those platforms in there. So highlighting them all, and I will drag them into platforms. And then because this is prefabbed, I can just click any old platform large, click the box collider, make sure that is set to be all the way up there, and then just apply that to the prefab. So make sure all of my large platforms have that new box collider. Give it a quick once over. We'll make sure we can land on this platform, press down. Yep, good to go there. And every other one should be working as intended. So I press down over here. Yep, we're good to go. All right. You know what? I like that a lot. And I think we're looking good. We're making good progress. Let's continue to add a few more additional features on the next lecture. This lecture, let's create this fun jetpack mechanic using a combination of 2D physics, a trail renderer, and our new input system all together inside of our player controller. Now this is going to be a pretty lengthy one, but let's take it one step at a time and import our player sprite inside of our player game object. I'm going to put this inside of visuals, open up my character sprite, and then we can just go ahead and lob this directly in here. If we actually just duplicate our cowboy hat and rename it, it already has a sprite renderer at the right position, or close to the right position, not quite. Let's name it Jetpack. And then we'll just go ahead and change the sprite to the Jetpack sprite, which you can find in the sprites folder. Let's go ahead and zero that out completely, and that should align just where we want it. That way, when we hit play, it'll go ahead and lean with the hat and the sprite completely as well. Very nice. Next up, let's make sure the input is rigged up so when we hit a specific key, our jetpack will fire appropriately. So we haven't opened it in quite some time. Where did we put our input? I'm just going to search for it manually because I can't remember. Inside of our player input actions, if we double click that, all we need to do is add an additional action. So let's hit this additional plus button. Let's call it jetpack. And what binding do we want to use? You can use whatever you'd like. I'm going to actually use the side mouse button to the left of my mouse. So I'm going to go ahead and click the path, click the listen button, and while holding this back mouse button, I'm just going to go ahead and select that. And that's all we need to do. So let's go ahead and save the asset. And then let's make sure that it's properly rigged up inside of our player input class. So let's open that up next. I'll go ahead and close that, search for player input. Great, that was convenient. And then let's properly rig this up. Now, we're going to get a little bit messy here with how many input actions we have. So I'm going to actually start putting this all in one line. So I've got my move here, and then I've also got my jetpack input action. I slightly prefer this syntax once we have a handful of values that are all not being initialized to any specific value. So down here, all we need to do is set jetpack equal to player input actions dot player dot jetpack, just as we assigned in our input actions. Next, let's go ahead and create a bool, just like we did for jump, to see if that input action key was pressed. So public bool, we'll call it jetpack with a capital J, and then up here, we just need to do the exact same thing as we did with our jump. So equal to jump dot was pressed this frame. Excuse me, a little typo. We definitely don't want to set jetpack equal to jump. We want to set that equal to jetpack dot was pressed this frame. And with that, I think we're all set to go ahead and introduce some jetpack logic inside of our player controller. So let's go ahead and open that up, and I'm just going to go ahead and close all of my other tabs. So what are we really trying to accomplish with our jetpack? Well, I'm basically just kind of looking for some sort of float or time value that we can go ahead and shift our rigid body physics up for just a split second, maybe like half a second to 1 second or so. And then for the visual effects, we're going to fire a trail renderer to kind of give that visual of a trail being emitted from our jetpack. So let's grab those two things we know we're going to need. We're going to need a serialized field or a private float, and I'll call it jetpack time. I'm going to set that to something like, 0.6 seconds, just to be slightly different than our coyote time, not too important. And then let's also grab a trail renderer. So I'll just put it right up top. I kind of like to put my game objects that I'm grabbing references to at the top. So private trail renderer, and we'll call it the jetpack trail renderer. Perfect. Let's go ahead and set up some of that logic down below. Now, I think the best way to do this is going to once again deal with an on jetpack sort of action to make sure that we can do a couple different things and then also eventually rig up the audio as well. So let's go ahead and do that. Let's create another public static action and we'll call it on jetpack. That way we can subscribe a few different things to it, both like our jetpack logic and if we need to, jetpack audio as well. So let's go ahead and create some logic at the very bottom to get our jetpack working properly and emitting that trail renderer that we'll set back in Unity in just a moment. So let's create a private void, something to handle input. So let's just call it jetpack for now. And then in here, we just want to check if basically our frame input of our jetpack is not being handled. So I'm going to use exclamation point underscore frame input dot jetpack. Then let's just go ahead and return. If we press that button, then let's go ahead and fire our on jetpack event. So question mark. So on jetpack, question mark, dot invoke. Nice. And then let's go ahead and start creating some additional logic for when we fire that event. So private void, I'll just call it start jetpack, something we can subscribe to our on jetpack event. And let's just go ahead and set our trail renderer to be emitting. Now we're going to do some trail renderer logic here shortly, but we haven't actually set that up in Unity, so I'm going to skip it for now to make sure that it all makes more sense shortly. So for now, all we want to do is start the actual physics of moving up. And I think the best way to do that is with a coroutine. So private IE enumerator, and we'll call it jetpack. Honestly, I don't even know if I should capitalize this P or not. I think jetpack is just one word, so I think we messed up all of these capitalizations above. Let's just go ahead and fix that real quick. So silly me, jetpack, and then I think at the very top I probably called it something like jetpack. Oh, see, look, I was going back and forth in between capitalizing P or not. What am I doing? So we'll set that as underscore P. All right, there we go, nice and clean. Let's scroll back to the bottom and introduce that logic. We'll call this private IE enumerator jetpack routine, and then we'll just use a while loop to basically go up the amount of the length of our jetpack float. So let's go ahead and create a float jet time. We'll set that to 0, and then while we'll go ahead and autocomplete. All we want to do is we want to check that if our jet time is less than our jetpack time that we've set as a serialized field up top, then we just want to move our rigid body up. So underscore rigid body dot velocity is equal to vector2 dot up times some sort of strength for how fast we want to actually move up. So let's call that jetpack strength, and we'll set that as another serialized float up top, something that we can modify in the inspector. So I'll go ahead and copy that field, scroll all the way to the top. I think the default hotkey to scroll really fast through VS Code is holding Alt, so I tend to do that quite a lot. And here, let's just create another serialized field that we'll call jetpack strength, and then we'll set that as something to relatively strong. I think somewhere around 11 ought to do the trick nicely. Scrolling back down, holding Alt nice and quick, we can go ahead and make sure we're timesing by our jetpack strength. And then inside this while loop, we just want to add to our jet time by time.delta time to make sure that is completing the while loop as intended. So jet time plus equals time.delta time. We don't need to return anything specific, so we can just go ahead and inside the while loop, we can just go ahead and yield return null. That way, at the end of this while loop, we can go ahead and be done with it. But I do want to make sure that we can't fire numerous coroutines at a time. In other words, if the player is spamming their jetpack key, I don't want them to just be able to start another coroutine if they're already in that coroutine. So let's go ahead and make sure we're actually setting this coroutine to a specific reference up top. Let's go ahead and scroll back up top once again, and let's create a private coroutine, and we'll just call it jetpack coroutine. That way, scrolling back down, I'm going to copy this reference. When we start our coroutine, we can set it to that reference directly and then make sure we're not firing multiple. So start jetpack. We want to start that coroutine, so underscore jetpack coroutine is equal to start coroutine jetpack routine. Great. And then up here, when we're actually checking our frame input, we can also check or jetpack coroutine is not equal to null, then we just want to return. Great, I think that should all be pretty close to set up. We haven't set up our trail renderer yet, but I think our physics of the actual whole thing should be working properly. I think all we need to do now is just go ahead and make sure that these are properly being fired up top, both in our events, and then make sure this input is being fired in update. So scrolling back up to the top once again, I feel like I'm getting dizzy. Right here at the bottom, I don't think it's too important where we put it. Let's make sure a jetpack is put in update for our input. And then right here, we can go ahead and subscribe to it as appropriate. So on jetpack, what do we want to subscribe? I think it was called start jetpack. Beautiful. I'll duplicate that, scroll it down, and then just make sure we unsubscribe to it as well with a minus sign. And then scrolling back down, after our Jetpack routine is complete and finished, we just want to make sure we're setting our Jetpack coroutine back to null to make sure that it's empty and our player can once again fire that Jetpack. At the moment, there's no sort of cooldown for our Jetpack, so as soon as the Jetpack is done, click, go ahead and fire it again. That's just fine. You could probably set up some coroutine cooldown to make sure you can only fire your Jetpack, maybe every few seconds or so, but for now, let's just make sure our physics is working. All right, that was a mouthful. Let's head back into Unity and see what it feels like so far. All right, let's hit play. I'm going to hit the back mouse button. All right, great. Probably can't see it because we don't have a ton of visual feedback, but I am indeed not jumping. I'm actually just pressing that back mouse button, and we're getting that cool little jetpack effect. So I can jump once, jump twice, and jetpack. Nice. I am liking that look a lot. Let's get some visual feedback for both our audio and a little trail renderer. So on our jetpack, we can right-click, create empty, and let's create a trail renderer. On here, let's add a component for a trail renderer. And what this is going to look like if I just blow up my scene view a bit. If I click and move this around, we have a nice trail renderer that we can attach to the bottom of our jetpack. So let's make sure that this disgusting, ugly purple is gone from my eyesight immediately. So to do that, I'm going to create a new material. I'll just put this in textures. And one thing that we can do is we can actually right-click, create a new material. Let's just go ahead and call this the Jetpack Glow. And if we actually change the shader to particle standard unlit, it by default comes with this HDR value. So because we don't need a specific sprite, we can actually just adjust this HDR value color directly. I'm just going to give it something like a nice sort of fiery orange glow like you'd imagine. Scroll the intensity up just a tad. I don't think I need it too much. I think it does need to be above the intensity value, so something like 1.6 probably is a good place to start. And if you're wondering why I'm not using my shader material directly, in my testing it did need to be that particle unlit shader, so we're using that specifically to make sure that it works in our trail renderer. And just like that, if we click our trail renderer and assign the material, open up this materials tab and drag that jetpack glow in, I think we should have relatively close to the effect we're looking for. I sure do love the boom effect. That is pretty. But my eyes are going quite blind. So let's pretty significantly lower the time down. I just needed the fire for just a split second, so something like 0.1 second. And then I'm just going to go ahead and at the very end of this width of the trail render, add a key, drag this down pretty significantly, kind of down to the bottom so it sort of peaks at the end. Don't even need it quite that wide, maybe something like, 0.7, 0.8, somewhere around there. That probably looks pretty good. Yep, I think that's actually a really good start. If I position that towards kind of the bottom of the jetpack, we can actually see that once we start flying around, even though we're not jetpacking, I think that looks about right. If I shift it up just a little bit, I think that'll look a little bit better. Still a little bit too wide for my taste. I think something right around there ought to be good. Now all we need to do is actually just go in and every single time we're jetpacking or not, toggle this is emitting sort of property in our trail renderer. So I'll go ahead and unselect it by default because now all we need to do is click our player, assign our trail renderer in the player controller, and then just create a little bit of additional logic to get that emitting back and forth. At the start of my jetpack, I just want to emit it. So underscore jetpack trail renderer. Oops, looks like I found another typo. So we don't want a jetpack trailer renderer. That's a bit silly. Well, we just want a trail renderer. So dot emitting equals true. And then let's make sure we rename that variable. So I'll highlight my whole thing. Hit F2 and then just rename that to trail renderer. When do we want to stop emitting it? Well, right after the coroutine is done. So I'll set jetpack trail renderer dot emitting to false. And that's all we need to do. Let's go try that out back in Unity and then we'll set up the audio as well. And because we renamed the variable, let's go into our player and reassign our trail renderer. With that set up, let's hit play and boom, cool. Every single time I hit that input key, we've got a nice little jetpack trail renderer. Yeah, I think that looks pretty good. We can jump, double jump, trail renderer. Yeah, we are super mobile and flying around. I'm liking that quite a lot. The last thing I'd like to do is just rig up audio, but because of our Eloquent Audio Manager class and our on event, it is super easy peasy. Let's go into our assets, audio, find our sounds collection SO, and let's create one more. Let's go ahead and open that up. Let's create a public sound SO for Jetpack with a capital J. And let's go create that sound back in Unity. So in my assets folder, audio folder, SFX folder, let's find my Jetpack. Let's see what that sounds like. Yep, super duper quiet. We're going to have to ramp that up. So in audio, sounds SO, let's go ahead and create a new one. So right click, create sound SO, call it Jetpack. Make sure that is an audio type of SFX. Clip, let's make sure it assigned to the Jetpack sound. Don't need it to be looping. Let's ramp the volume way up, probably close to the very top. Don't need to randomize pitch. I think everything else looks good there. Let's make sure that's assigned in our sounds collection. So Jetpack plus, we'll assign the Jetpack sound SO. And last but not least, we can open up our Audio Manager class and subscribe to that on Jetpack event. Let's open up our Audio Manager. So open up the SFX region, create a private void player controller underscore on Jetpack. Nice. We want to play a random sound. We want to go into our sounds collection SO and play our Jetpack. Go ahead and collapse that, open up our Unity methods, and let's go ahead and subscribe and unsubscribe to it. And I'm just going to do it right by my other player controller event. So player controller dot on Jetpack, and let's fire our player controller underscore on Jetpack sound. Nice. Duplicate that, slide it down, and make sure we unsubscribe to it as well. Yes. Man, look how nice that was. Because of the good code architecture we have with everything rigged up in place, it's now super easy to go ahead and add more features. I love it. Chef's kiss. Mwah. Beautiful. Let's head back into Unity and see what that sounds like. Cool. With it playing, all of my sounds are working. Hey man, you can just barely hear the Jetpack. My Jetpack sound is so quiet. So I think you know what we need to do is go into our sounds SO, open that up, and then I'm just going to make sure my volume value is going to allow us to ramp it way up. So something like volume 0.1 to 4, just to get my Jetpack sound sounding significantly louder. Let's go try that out. And fingers crossed, I hope that didn't reset all of my other values. I don't think it would. So assets, audio, sounds SO. So they should all still have their own default sound values. Great. All right, and with that at 4, let's blow up my game view and see if everything works. Yeah, you know what? The visual effect looks great. It's still really quiet on my end. You can probably actually barely hear it over the music while I'm talking, but I indeed can hear it. So I'm pretty satisfied for now. If I wanted to go ahead and polish this off, I think we can do it in the polish section. I might continue to mess around with my sounds and things like my music and my bullet, maybe ramp those down. And then I could actually, in turn, ramp the Jetpack up a little bit. But for now, I don't want to spend too much time on it. And then let's fix one more thing back in our player controller before we move on. Just a couple more typos from me in my player controller. So I'm going to go ahead and correct Jetpack time to not be a capital P. So highlight Jetpack time. And I'm just going to change that to lowercase p, just like all of my other Jetpack naming conventions. And then somewhere else we have, right here, Jetpack coroutine, F2, and then I'll replace that as well to just the lowercase p. All right, with everything working correctly, that was a pretty long and intense lecture. We got a lot done. So give yourself a nice pat on the back. When you're ready to move forward to the next one, I'll see you there. In this lecture, we'll be facing our biggest challenge yet, which is going to be recreating this grenade on your own. Now, we haven't had a challenge in quite a few lectures, so I'd like to take some time and really flex your game dev muscles in this lecture. This is going to be a meaty challenge for you. We're going to be putting together a lot of different systems and mechanics that we've talked about throughout this course and really bring it all together on your own to recreate and simulate this sort of grenade mechanic on your own. Now, this is probably going to take a while. I would highly recommend that you take some time and really struggle through it, putting everything together on your own. However, just like every other challenge, put your best foot forward, take some time to do it on your own, and then if you can't actually accomplish one or two little things in it, that's okay. This is a hard one. We'll come back and I'll go through it together with you step by step to make sure that you can see how I put it together, and then you can implement what you need on top of it. So now that we've seen the preview of what this grenade really looks like, let's officially talk about this lecture's mega challenge, which is going to be recreating that grenade as seen in the preview completely on your own. Now there's a lot of steps to it, so here's some additional steps that you can take to kind of compartmentalize and how to break this down step by step. So in no particular order, you're going to need to do all of these things. You're going to need to create a grenade prefab using the sprite found in the sprites folder. You're going to need to rig up player input to launch the grenade. Now you can of course use whatever input you'd like. I'm going to use right click. You're also going to want to lob the grenade and spin it a little bit using its rigid body. So to spin it, we haven't actually talked about add torque before. That can actually get it rotating around in the right direction. And you can also things like rigid body.add force in that force mode to the impulse mode that we've used a few different times to kind of lob it like a grenade would through the air using 2D physics. I'd also like you to beep it 3 times before it detonates using both visual and audio cues. So visually, you can see in the grenade, I have that little bit of a light flashing. You could achieve that with either a 2D light or a little bit of a bloom effect. I'd also like you to rig up the audio manager for both the beep and the explosion. Now that's a little bit of a gotcha. There's a couple different ways that you could go about setting it up, but put your best foot forward and see if you can figure it out on your own using the system that we have in place. Next, create an explosion particle system VFX and shake the screen when it detonates or collides with enemies. So in other words, it's going to explode after it beeps 3 times or if it collides with an enemy slime. Additionally, you're going to want to damage and basically blow up all the enemies. So I would have the grenade do 3 damage. The enemies have 3 health. So in other words, don't really need to worry about knockback too much at the moment. Just go ahead and blow up the slimes or basically destroy them if they get hit by the explosion. To do that, I don't think we've used physics 2D overlap circle all yet. So I would use something along those lines to make sure that you can hit multiple slimes at a time when your grenade explodes. Okay, let's watch the preview one more time to kind of see how that all comes together. Nice. Exploding correctly. Let's see if we can get it to beep correctly. I heard 1 beep. I gotta stop hitting slimes. Alright. Beep. Nice. This is gonna be a meaty challenge. I can't stress enough. Try your best. If it takes 20 minutes or 2 hours or even more than that, it genuinely wouldn't surprise me. Alright, now is the time to pause the video before moving on. In the next lecture, we'll start going through a solution together. I'll see you there. In this first part of the solution to the Mega Challenge, let's re-rig up some of our input to get our grenade firing from our gun. Alright, we've got a lot to do. I'm going to directly start updating my input. So I'm going to go directly into my player input actions and we can update it there. Now, I've also noticed we've never actually updated the input for firing our gun, so we'll do that in the polish section. I don't want to get too overwhelmed at the moment. So for now, all we need to do is add an additional action, and I'm just going to call it grenade. And I'll go ahead and set that to my mouse right click. With our player input action saved, let's actually just go ahead and immediately rig that up in our player input. So with our player input class open, let's go ahead and add an additional input action. Let's just call that underscore grenade. In here, we just want to set underscore grenade equal to player input actions dot player dot grenade with a capital G. Now scrolling down to the bottom, in our frame input struct, I'm going to do this as a bool, and we'll just call that grenade as well with a capital G. Up here in our private frame gather input, well, we just want to set that to be just like the other logic of the other bools and set grenade equal to underscore grenade dot was pressed this frame. Let's go ahead and open back up Unity and get some things in place like a prefab and some particle effects in place so we can use that in a custom grenade class. And I'm going to go ahead and put that custom grenade class directly in my gun folder. So assets, scripts, and gun. Let's go ahead and right click, create, and create a new class called grenade. And we can put all of our custom grenade logic inside of this class. Now, some people prefer to actually do the programming first and then do things in Unity. You could totally do that. I kind of tend to prefer to do Unity-related things first, like setting up prefabs and particle effects, getting all of those in place, and then rigging them up in code. So I'm going to go ahead and create my prefab first. So in my assets and in my sprites folder, let's go find that grenade. So in our player folder, I'm just going to go ahead and drag that sprite directly into my scene. And what are we going to need on this grenade? Well, we're definitely going to need a capsule collider. So let's go ahead and rig that up. Now we have to ask ourselves, do we want it to be a trigger? I don't want it to be. I kind of want it to roll on the ground and things like that. So I'll edit that collider just a tad, probably to something around there. So there's a little bit of an overlap on the pixel itself. And I definitely also want my layer to be friendly because I don't want it to interact with our player directly. We're also going to need a rigid body 2D. I'll go ahead and add that. I think everything looks good here. The only thing I'd like to change is this collision detection to be continuous. It's probably not too important because it's not moving too fast, but I would like to make sure that when it hits the enemy, that detection is getting properly detected. What else do we need? We want our custom grenade class. We'll go ahead and rig that up in a second. And I'm also going to want some screen shake. So while we're here, we can also add a cinemachine impulse source, and we'll modify that shortly. We can use this so that way when the grenade explodes, it's using its own custom impulse source logic and values. So I'll change that to something like explosion. I think 0.2 probably sounds about right. And we're going to want it to be a bit more drastic than anything we've done so far. So for now, I'm just going to set it to something like 0.3 on both the X and Y, and that'll give us a pretty good screen shake. I think in the polish section, we're going to add some additional logic and basically detecting how far away the grenade is, and that'll actually determine the value on how much it shakes. But for now, let's just make it relatively simple. And we're also going to need some sort of visual light grenade beep. Now, there's a couple different ways you could have gone about doing it. I'm actually just going to do it with a little bit of a bloom material. So I'm going to create an empty, we'll call it grenade light. And on here, I'm going to add a sprite renderer. And I just want this to be a 1x1 pixel sprite. Something that we can just go ahead and put directly on top of the light. And if we change this material to be kind of that glowy green with our shader material, that'll give us that nice sort of flash we're looking for. So instead of using this spritelet default, assets, materials, and shaders, I'm just going to duplicate my teal glow material. And I'll name it Grenade Light Glow. And I'm just going to change mine to a nice bright sort of green. And let's actually see what that looks like after I add a texture. So what do I want it to be? Probably just that 1x1 texture sprite. So 1x1 pixel as my texture for my main text. Now if we drag that material on here and then modify it, so I think I just need to ramp up that intensity a bit. Okay, I think we just need to actually add a sorting group and make sure that is getting sorted correctly. So on my grenade, I'm also going to add a sorting group. There we go. And now it's appearing correctly. Yeah, there we go. That looks actually about right. I'm just going to go ahead and make sure my sorting group layer is set to default. Let's just change it to VFX so it appears, in front of the player and things like that. We'll set that to an order layer of 0. We'll make sure my light is always ahead. So VFX and 1. Even though this technically doesn't matter because it's a child of that sorting group, but I think that's kind of the visual effect that I'm looking for. Maybe even just a tad brighter and I think we're set to go. So maybe something around there looks pretty good. That way, all I have to do is toggle this grenade light off and on when it beeps. So we'll go ahead and toggle it off by default. I'm going to drag my grenade script up to the very top of this game object, just so that way I easily have my serialized fields up here that we can modify. The last thing we're going to need in Unity before we hop into our grenade class is that explosion particle effect. Well, luckily we already have something relatively close. So let's go ahead and prefab this grenade and then we'll set that up next. So prefabs, layer, and now I'll just go ahead and drag my grenade in to make sure that's prefabbed as well. Next up, let's go into prefabs, VFX, And I think the base death VFX is going to be pretty close. We just need to modify a few things. So I'll go ahead and duplicate that, and we'll call it grenade VFX. Let's call it explode VFX, I think is more reasonable. Let's drag that into our scene and we can start playing around with it. Now the first thing I'd like to do is just add a bunch of bloom to it to kind of get it that sort of nice visual glow sort of thing, like you'd expect an explosion to be. So in our renderer, instead of using the border particle, I'm going to go into Assets, Materials, Shaders, and then one more time, I'm just going to go ahead and duplicate this. We'll call it Explosion Particle. I think that makes sense. And then in here, we want to change the texture to the no border particle texture. Either would have probably been good. And we're just going to go ahead and add somewhat of an orangish red, probably relatively bright, but let's take it one step at a time. With my prefab selected in the hierarchy, scrolling back down here, let's go ahead and drag that explosion particle in before we start modifying it. So right now, okay, well there you go. That's actually pretty close. So I don't really need to do much there. I think the only things that I'd like to do is maybe just make my start speed a little bit bigger, kind of like you'd imagine an explosion to be. So something like 9. Maybe start lifetime a little bit shorter since it's kind of a nice quick burst. Yep, I think that looks pretty good. I think my start size could probably be a bit bigger. I'm going to change it to random between two constants. You know what? Probably 1 to 2 is going to be pretty close. Yeah, I think that's pretty close. I'm going to go into my emission. I just want a few more particles on that initial burst. So let's see what double looks like. Yeah, you know what? I think we're pretty much about there. That looks pretty good. We can go ahead and modify that more later if we'd like. For now, I'm pretty satisfied. So I'll go ahead and apply those changes to my prefab, and I will delete that from the hierarchy. With those prefabs in place, let's go ahead and start, not directly in our grenade class actually, let's go ahead and open up our gun class to get that grenade instantiating when we press the right-click mouse button. So, gun, and let's open that up in VS Code. I think it makes sense to have another public static action on shoot, except we can just go ahead and call this one on grenade shoot, and then we can kind of start subscribing everything to it just like we did for our bullet. Now we're going to have quite a few serialized fields. I think it makes sense to organize this a tad. So I'm going to create a header, and I'll call this bullet. And then we'll create one more, and we'll call it grenade, just to kind of organize our serialized fields a bit. So scrolling that down, we can actually use the bullet spawn point for both, so I'll drag that up. Let's see, bullet, bullet, bullet. I don't really want to flash my muzzle necessarily, so I'll go ahead and leave that in the bullet. And then we're also going to need a float and a prefab for our grenade. So serialized field, private game object, and we'll go ahead and grab a grenade prefab. Very nice. Next, let's also do the same, except we'll grab a float. So I'm just going to duplicate that line. And let's go ahead and grab a float for grenade. Next up, what am I going to need? Well, I'm going to need some sort of fire CD, just like we did for our bullet. So I'll duplicate that line, slide it down, and I'll just call it grenade shoot CD. So grenade shoot CD. Now, I probably want it to be a bit longer, so maybe something around, something a bit longer. So let's say 0.8 seconds for now. And we can follow a lot of this same logic. So let's see, instead of a private float for last fire time, we can just go ahead and duplicate that, and we'll call it last grenade time. And we can follow a lot of the same logic we have below for firing our bullet. The only different part that we're going to need is before, I think we're actually still using the old input system for firing our bullet. So, should we do both at the same time? I think we can come back to that later. We've got already plenty to cover in this section. So we are going to need our input. So how do we do that? We could get it directly from the player controller, but I think there's enough input in our gun that I'm just going to go ahead and grab my input for my frame input directly in my gun as well, just like we did for our player controller. So private player input, I'll call it player input, and we can go ahead and get that on awake. So player input equals, we can just get the component in the parent since we know that's on our player controller and our gun is a child game object of that. So get component in parent, we'll grab player input. And we're also going to need frame input. So private frame input, We'll call it frame input. And we want to make sure that after we grab player input, we can also grab frame input as well, but it definitely needs to be after player input because we need to set that equal to player input dot frame input. Next in update, we need to create some sort of gather input functions. So below our public methods, private void, gather input. And in here, we'll set frame input equal to be player input dot frame input, just like we've done in our player controller. And we'll go ahead and call that in update, but we want to make sure it's at the very top. So gather input, there we go. Now scrolling down to our shoot method, we can actually follow a lot of this same logic. So what do we need to do? We need to reset our last fire time. Let's go ahead and do that. So let's copy paste that previous method, except instead of resetting last fire time, we want to reset last grenade time. And instead of using our gunfire CD, we want to use our grenade shoot CD. Great, nothing fancy there. And instead of resetting our last fire time, let's just reset last grenade shoot time. There we go. And where did we put reset last fire time? I think we actually did that as an event, so let's get some of that rigged up. So instead of using this old input system, let's just do it from scratch. So we want to say if underscore frame input dot grenade, because we know it's a bool, so we can just check to see if we've hit that button. And then we'll go ahead and use that time is greater than or equal to last grenade time. Now, we definitely could have set this up with time.delta time. You know what? I'm kind of regretting it. Maybe we'll handle it in the polish section, but it's not too important. If we fulfill both of those bools and they both return true, let's go ahead and on grenade shoot $.invoke to fire that event, but we haven't subscribed anything to it yet. So just like we did for our bullet, we want to shoot something. So below shoot projectile, private void, shoot grenade. And all we want to do is instantiate our grenade. Just like we did for our bullet, we're not going to worry about object pooling our grenade, even though you definitely could. For now, let's just go ahead and instantiate grenade prefab at our bullet spawn point dot position. And we don't need to worry about rotation yet. So quaternia.identity seems completely reasonable. Then we'll set last grenade time equal to time.time. And then we can actually just subscribe our on grenade shoot with shoot grenade, fire animation probably makes sense, and reset last grenade shoot time. So let's go ahead and do that on enable. So on grenade shoot plus equal shoot grenade. And we'll make sure we unsubscribe to it as well. So let's make sure we put our minus sign and we'll duplicate it 2 more times because we know we're going to actually subscribe those other 2 things as well. I would like the fire animation. So I'm just going to go ahead and copy that here. So I've got my fire animation for both my on grenade shoot and on shoot. And then last but not least, I want to reset last grenade shoot time. So I'll go ahead and subscribe and unsubscribe to that as well for on grenade shoot. Okay, I think we've gone far enough before we need to move forward. Let's definitely do some additional testing back in Unity. And I think if we've done everything properly so far, we should just have the grenade instantiating in our scene. It's not going to do anything at all other than just kind of fall to the ground. So in our gun, let's go ahead and find our grenade prefab. So I'll go ahead and click the lock button. And then let's go ahead and find our prefabs folder. So assets, prefabs, player. And we'll go ahead and drag our grenade prefab in. All right, let's actually see if that works so far. So if I hit the play button and right click, good, I should have my grenades being instantiated into the scene. If I spam the right click mouse button, we can actually only fire it every single time our cooldown has been refreshed. Great, everything seems to be working so far. Let's go ahead and write some additional logic inside of our grenade class. And we'll handle that in the next lecture. I'll see you there. In this lecture, we'll move forward with part 2 of the solution, not only getting our grenade firing from our gun, but getting it exploding as well, using those prefabs that we've created. Let's open up our grenade class that we created in the previous lecture. Cool, well let's grab some references we know we're going to need right off the bat. I think the most obvious one is going to be our rigid body. We'll call that rigid body, and we'll go ahead and grab that in awake. So rigid body is equal to get component rigid body 2D. Nice, what else are we going to need? We know we have a impulse source, we can go ahead and grab that. So using Cinemachine, there we go. Now we can go ahead and grab our private Cinemachine impulse source. There we go. And we'll just call it our impulse source. Now we have those two components that we know we're going to need that are already attached to our game object prefab. Let's make sure we grab that reference. So get component, Cinemachine impulse source. First and foremost, let's just get it kind of lobbing through the air. So how can we do that? Well, we already have our grenade being instantiated. We didn't actually verify or necessarily figure out where the player was aiming. So we could either do that on start. I think in our bullet, when we instantiate that bullet, we have some sort of init function for our bullet. I think for our grenade, because we're not object pooling it, let's just simplify it and put it on start for now. And we'll call that private void launch grenade. Well, how are we going to do that? We need to find our mouse position, so we should be familiar with that. Vector 2, we'll just call it mouse pause, and we'll find camera.main.screen to world point to see where our mouse is, and we'll take in our input.mouse position. Next, just like we did for our bullet, we need to normalize it. So vector 2 dot direction to mouse, and we'll take in our mouse position minus our transform dot position, and we'll go ahead and normalize it. But we're getting a compilation error because we need to cast this specifically as a vector 2. Let's see if that'll work. I think we just need to capitalize our V. And there we go. We just want to dot normalize that vector just like we did for our bullet. Now that we have that direction, let's just basically add some impulse directly in that direction to our rigid body of our grenade. So rigid body dot add force, and then we just want to go in the direction to the mouse, and then we probably need some sort of float value here that we haven't created yet, for the strength or the amount that we're actually launching that grenade. So for now, we'll just call it launch force, and we'll go ahead and create that in a moment. And what do we want to do? Let's just use force mode 2D.force as we've done several times before now. I think if VS Code will let me, I can highlight this, press Control dot, and then generate a field for launch force. Ah, so close, except tried to create it as a vector 2. Not terrible. Let's go ahead and create it just as a float for now. And let's make sure we serialize that field so we can modify it in the inspector if we'd like. And we probably want something decent. For testing, I know something around 15 is relatively close to the effect we're looking for. So we've got a serialized private float for our launch force at 15F. Great. Next, let's actually do the exact same thing, except we want to rotate it slightly when it launches, just to kind of give that visual effect that it's being launched properly like you'd suspect a grenade would. And how do we do that? We can use our physics2d.add torque directly to our rigid body. So same thing, let's create a float called torque amount that we haven't created yet, and then we'll also use force mode 2D.impulse just like we've done before. Let's copy and duplicate that launch force. We'll call it torque amount, and then we probably don't need something so severe, so something around 2 will just give us that kind of light, sort of slow rotation. On start, let's just fire that function we created, so launch grenade. Alright, nice, we're off to a good start. Oops, little bit of a typo by me. Force mode 2D not.force.impulse. Okay, with that set up, I think we've got plenty to go test out and try back in Unity. Let's head back into Unity and see what it looks like. Alright, let's hit play and right click. Cool, there you go. We've got our grenade firing through the ground. I think I've applied way too much torque. Let's go ahead and adjust that. I think I was maybe looking for something like 0.2, so play, click. Yep, I think that looks about right to me. So just kind of a nice, slow, simple lob as we fire our grenade. Nice, we're off to a good start. I think the next most logical thing I'd like to create is just sort of an explosion when it hits our enemy. So let's go ahead and do that next. Opening back up our grenade class, let's go ahead and attach that prefab that we created, that explosion. So private, game object, and let's just call it, what should we call it? Yeah, let's just call it explode. VFX I think makes sense. And when do we want to fire this? Well, let's go ahead and create an action to do so. So for now, let's import the system namespace. Let's call it public action on explode. Now, I'm not going to make it static yet. I probably won't ever want to do that. We have to ask ourselves, do we want this action to be attached to the class specifically, or do we want it to be attached to the mono behavior instance of this class? Well, in our case, we're going to have a few different grenades. So I think we just want to make it a public action, but that might make our audio manager a bit tricky. We'll talk about that in a moment. For now, let's go ahead and just create a on collision enter 2D. And if other.gameObject.getComponent is our enemy, well, then we basically want to explode. So let's go ahead and fire that event. So on explode, ?.invoke. And let's create that explosion. So private void, we can call it explosion. Nice. What do we want to do? We want to instantiate our particle effect prefab. So instantiate explode VFX at the transform dot position. And we don't need any sort of rotation, so quaternion dot identity. What else should we do? Well, let's just go ahead and destroy the grenade right here for now. So destroy game object. Next, let's go subscribe to that event. So on enable, on disable, on explode plus equal explosion, and we'll unsubscribe to it as well. So we'll change that to a minus sign. And you know what? I think we can also go ahead and kill two birds with one stone. Let's test a couple things at once. Let's also give ourselves a little bit of a screen shake. So private void, let's call it grenade screen shake just to be explicit. Grenade screen shake. We'll go ahead and go into the impulse source, generate impulse. Now, I do think it would be cool to kind of detect how far away from the explosion we are. I think we can do that in the polish section. So for now, let's just fire that default screen shake. So on explode, we want to subscribe to screen shake, whatever we called it, grenade screen shake. Very nice. And we'll unsubscribe to that as well. Let's go try that out back in Unity. Let's just go into the prefab directly, and then we can find our prefabs, VFX, and our grenade explosion. So there we go. Let's go ahead and drag that in. There we go with that assigned. Let's go ahead and hit play. I think we're going to need to hit a slime to make sure that it works. Nope. Okay, well, there we go. Yeah, I kind of did it on the first try. Good job, me. Nice, we have everything working. So we have the explosion so far. We have a little bit of a screen shake, and I think we're off to a good start. Next up, let's go ahead and actually do some damage to each individual enemy that we hit. Now, this part's a little bit tricky because we want to be able to hit more than one enemy at a time. So this is where that overlap sphere circle sort of function comes in. And we'll implement those features on the next lecture. When you're ready to move forward, I'll see you there. Up, let's go ahead and work on getting an explosion and contact, making sure our slimes are appropriately taking damage on explosion. Let's get that rigged up. So opening back up our grenade class, let's create another private function, and we'll call it private void damage nearby. I think that makes sense. And let's go ahead and get all of the colliders within a distance that we can grab in an array that we'll just call hits. To do that, we need to go grab physics2d.overlap circle all to make sure it returns all of the colliders that it comes in contact with. We'll start that at the transform.position. And then we also need two different other parameters or properties that we can pass through. We need a explosion radius, and we also have an optional overload for the layers that we'd like to touch. I think that actually makes sense to do it that way because I don't necessarily need the collider for, say, like our tile map, our pipes. What else has a collider? Really anything else but the enemy for now. So let's go ahead and create both of those up top as well. Let's create another float, and I'll call it grenade. Let's call it actually explosion radius. And through testing, I think something like 3.5 units is going to be about right. You can make that bigger or smaller than you like or kind of match it to the way that you have your particle prefab. But for me, I think that's about right. We also want a serialized field or a private layer mask, and we just want to make sure that we set that to the enemy layer mask back in Unity. So enemy layer mask, and we can pass that through as an optional overload. So let's go ahead and pass both of those through. We have our radius and our enemy layer mask. All right, some sort of compilation error. Let's see what we've got here. We have a radius, we have a layer mask, we have a position. There we go. Collider 2D. Next, we just want to cycle through all of those colliders. So we can do that with a for each statement. And let's just say for each collider 2D, inside of hits, we can just call it hit for each individual one. We know we're actually only grabbing the enemies because we're going to use this enemy layer mask. So let's go grab that health component. We'll call it health with an undercase H, and we'll say hit.getComponent elf. Next, let's go into health, and all we need to do is take damage. So take damage, and for now, let's just use a magic number and manually pass through 3. Actually, I changed my mind. Ugh, that just feels dirty. I changed head to the disgusting, Steven. So private serialized field, private int, we'll call it damage amount, and we'll just set it to 3. Much better. I can now sleep at night. So with that passed through, we should now be able to destroy or basically kill each individual slime that it hits. Each individual slime is going to die. Each individual slime is going to take damage, have its own sort of particle effect explosion, and I think we're all set to go. All we need to do is subscribe our damage nearby function to our onExplode. So let's go ahead and do that. So duplicating both of those lines, I'm going to also hold Alt to modify both at the same time. Holding Control, Shift, and left arrow, I can highlight the entire word and damage nearby. There we go. Nice. Let's go try that out back in Unity. All right, and with my grenade prefab still open, let's go set my enemy layer mask equal to enemy, except we don't have that set yet. Cool, so let's go ahead and create one. So layer, add layer, and then let's just add a enemy layer mask. Enemies, and on our slime, let's just set that layer equal to be enemy and change all of the children to it. Back in our grenade prefab, let's set that enemy layer mask to enemy. And I think everything should work as intended. So let's hit play and see where we're at. So right click, explode. Hey, there you go. It is now exploding and destroying enemies that it comes in contact with. Let's wait until a few different slimes are all bunched up and gathered together and actually see if we can destroy a few at once. Yeah, there we go. We are causing mass destruction. Nice. We're making good progress. I think before I handle audio, let's go ahead and continue finishing off the additional functionality of our grenade and get those 3 beeps before it explodes. So let's open back up our grenade class again. And let's create a couple more serialized fields. Let's create a serialized field for how long we'd like it to beep. So private, float, and we can go ahead and call that my light blink time. And we can set that to something just like a split second or so, so something like 0.15f ought to do it. Let's create another serialized field, and let's just call it the total number of blinks unless we want to change it to blink a little bit faster or slower on our own. So private integer, we'll call it total blinks, and for now we'll just set it to 3 because we know we want 3 to start. Now we're going to need a way to keep track of those, so let's create another private integer called current blinks. I'm going to use a coroutine to basically keep track of how many times it blinks. And we'll call that underscore blinks with an S at the end. And what do we want to toggle? Well, we also need a reference to that little bit of a game light that we created back in Unity, which we just have as set as basically that blue material that we want to flash on and off. So we need to grab a reference to that as well. So serialized field, private, I'm going to go ahead and grab that as a game object since we want to toggle the activity in our hierarchy. And we'll call it grenade light. And we'll make sure we set that reference back in Unity on the prefab directly. So when we start and basically fire our grenade, I'd like to create a private IE enumerator, and I'm going to call it countdown explode routine. Inside here, I'm going to do this inside a while loop. And how long do we want to do this? Well, we basically just want to check to see how many blinks we have. So we can do that by saying, while current blinks is less than total blinks, then we basically want to just wait a second and then beep every once in a while. So yield, return, new, wait 4 seconds. And this is where I'm going to get a little bit fancy and make sure we're just doing a little bit of algebra to make sure it's easily modifiable. You know, maybe we want our grenade to explode after 7 seconds, but have 12 beeps or something like that. So let's go ahead and create one more integer as a serialized field. So I'll duplicate that line and I'm going to call it underscore explode time for the amount of time we actually want to wait before the grenade explodes. So I'll go ahead and set mine to 3, basically, so every single second it'll go beep, beep, explode. Well, we can modify this as needed. So explode time, and this is where we can get a little bit fancy with our basic algebra. So explode time divided by the total amount of blinks. After that, we basically want to beep, but we haven't set up that event yet. Let's do that in a second. We flash that light on and then we flash it back off. So yield, return, new, wait 4 seconds, and then we'll pass through our light blink time. After that, let's go ahead and set my grenade light, set active, back to false. After that while loop is complete, well, what do we want to do? We want to explode so we can go ahead and fire that event. Next, we just need to create an on beep event because we'll do a couple different things. Not only are we going to flash our light, but we're also going to cue into that with our audio. So at the very top, public action, on beep. Very nice. Let's go ahead and fire that event when we're beeping back in our coroutine. So on beep, question mark, dot, invoke. Now we haven't subscribed anything to it. Let's go ahead and do that after we fire this coroutine on start. So start, coroutine in start, and what coroutine do we want to start? Countdown, explode, routine. Next up, let's subscribe a couple different things to our on beep event. So right here at the bottom, let's create a private void and let's call it blink light. In here, all we need to do is set grenade light to set active true, and then let's also add to our current blinks up top. So current blinks plus plus, just to make sure that's getting kept track of correctly. And for now, I think that's all we need. So let's go up to the top. And below on explodes, let's go ahead and create an on beep plus equal blink light. And let's unsubscribe to it as well on disable with a minus sign. Nice. All right, let's go see how we did back in Unity, and then we can rig up audio next. And before we hit play, let's just drag our grenade light into our grenade light reference. And let's see how that looks. So right click, we have a beep. Great. Beep. Okay, it hit the enemy. Let's come on over here. We have beep 1, beep 2, and explode. Nice. There we go. And with that, I think our logic is done. Not only are we firing our grenade, it explodes and destroys multiple at a time. But on top of that, we're actually getting that 1, 2, and 3 beeps. Perfect. Our logic is complete outside of our audio. So let's go ahead and do that next and wrap up our grenade in the next lecture. I'll see you there. This lecture, let's go ahead and wrap up our grenade, introducing audio for both beeps and our explosion, as well as our grenade launch sound effect. Let's get that set up. And just like I did before, I kind of like to do things in Unity first. So assets, audio, and sounds SO. Let's go ahead and right click, create a new sound SO, and let's call it grenade explode. We can duplicate that and also create a grenade beep. So our grenade beep, we want to set that clip to our grenade beep. Great. I think that sounds about right. I'm actually just going to increase my pitch just a little bit. Not sure if the volume is right, but it's probably pretty close. Don't want it to loop, don't really need it to randomize pitch, however you could. And on my grenade explode, I'll set that also as SFX, clip to explode. Yep, sounds pretty good to me. And we'll leave everything else as is for now. But I am forgetting actually one additional sound we need to create, which is, let's duplicate one more. That's when we fire our grenade from our gun. So let's call it grenade shoot. And we'll set that equal to be our grenade shoot. Now, you can probably just barely hear it when I play my audio. Play that one more time. Pretty quiet. So we probably want to increase the sound a bit, but more importantly, what I was looking to accomplish is I think it's going to sound really cool if we go into our grenade shoot, and I'm just going to lower the pitch a tad. I think that'll sound really nice. Maybe increase the volume by just a tad as well. And we'll see how that sounds. Next, assets, audio. Let's find our sounds collection and get that set up. And let's open that up in VS Code to create those sounds. So I'm going to need 3 more. So 1, 2, 3. We'll create a grenade shoot, a grenade explode, and what was the other one? Grenade beep. That's what it was. Grenade beep. Nice. Let's go create those methods in our audio manager. So audio manager. And I'm just going to scroll all the way down to my region SFX first and foremost. We can go ahead and close these Unity methods. And let's create 3 different methods that we can use as needed. So private void, grenade, we'll call it on beep, and we'd like to play a random sound. So play random sound. I'd like to go into my sounds collection so dot grenade beep. Nice, we haven't set that up yet, but we have the method now. I'm just going to go ahead and duplicate this 2 more times. We want to go into our grenade on, what was it called, on explode. And I'd like to play my explode sound. Great. And the last one is not actually in grenade, it's in our gun. So I'm just going to call it gun underscore on grenade shoot. Let's go ahead and make sure that's what that was named. So gun, scrolling up, on grenade shoot. Great. Good naming convention. And then we'll just go into our sounds collection so on grenade shoot. So what was it called? Grenade shoot. There we go. Now let's go ahead and get our gun rigged up first because the grenade is the little bit of a gotcha. So let's go ahead and get those set up second. So the gun is actually very easy. So region, Unity methods. Let's go into our gun. So right here. So gun dot grenade shoot plus equal gun underscore grenade shoot. Great. Copy that line, paste it down below here, and then just make sure we're unsubscribing it with a minus sign. And let's head back into Unity and just make sure that looks and sounds okay. Nice, and to rig that up, let's go ahead and on our shoot, explode and beep, we can go ahead and set those references. So plus, plus, plus. Shoot is shoot. Grenade explode is the explode. So grenade explode, nice. And grenade beep is indeed the grenade beep. There we go. All right, let's hit play and see how that sounds. Let's make sure our sound is enabled. Click play. And let's see if we can listen for when the grenade is launching. Nope, definitely not the right one. Did I click the right? I think I clicked the wrong one. Let's see. So let's see how we got here. Grenade shoot. Ah, I selected the shoot. Did you catch that? Let's make sure we have the grenade shoot reference correctly installed. And there we go. At least we know everything is working correctly. So right click. Yeah, that sounds good. A nice sort of deafening, low pitch sort of plunk. Yeah, I think that sounds really good. I'm going to just turn mine up just a tad because I quite like it a lot. Actually, I'm going to turn my fight music down. So volume in my fight music down here. Grenade shoot. I'm going to turn my volume up just a little bit more. Let's see if we can listen for it. Yeah, I like that sound a lot. Okay, now the grenade exploding and the beep is a little bit trickier. And why is that? Well, if we open up our grenade class, we actually don't have this as a public static action. So how can we actually gain access to it? Well, if you remember when we did our public actions on health, we basically just passed through the health class. So I'm not going to do it that way necessarily, but you could do something like this. So you could pass through the grenade on each individual one of these functions. So for example, like let's say our explosion. Now you don't have to do this, but just following along for a second. You could say something like grenade. You could pass through the sender. And the tricky part with this is actually going to fire the event because it's static through each individual grenade on the screen. So you would additionally have to do something like if sender is not equal to this or something along those lines, then return. Now, it's not terrible. There's only going to be, 3 or 4 different grenades on screen at once. So this would work. There's not necessarily anything inherently wrong with it. Then you could actually follow the same pattern in our audio manager. And that part I actually do like. But this part, I don't love it. So the way we're actually going to do it is just not do that at all. I'm going to actually just break my pattern a bit. And this is the tricky part with code architecture because I wouldn't say necessarily one is right or wrong, but the way that I'm going to do it is go back into my public action. I'm not going to make it static. I'm not going to pass through the grenade. I'm just going to actually simplify it. And then in here on grenade, I'm going to subscribe to my audio method. So in my audio manager, where I have these grenade on beep and grenade on explode sounds, I'm going to change both of these to public instead of private. And then we can actually just subscribe to these in our each individual grenade mono behavior action. So on enable, we have on explode right here. So on explode. And then I can go into my audio manager and we could do that in a couple different ways. We could just find that directly in Awake. Let's just do that. I think that's just fine. We only ever need to do it once per grenade. Alternatively, you could probably turn your audio manager into a static instance because we only know there's ever going to be one and just do a little bit of a singleton. You know what? There's not necessarily one that's right or wrong. I slightly prefer the singleton, so let's actually do that. So on our audio manager, here at the very top, public static audio manager, and we'll just call this instance just like we did on our player. So in awake, we can just say if instance is null, then instance equals this. Really super duper simple singleton because we know we're ever only going to have one audio manager in our scene. That way you can go into the grenade and say audio manager dot instance dot grenade explode. We can unsubscribe to that as well. So duplicate it, slide it down, make sure we change that to a minus sign or you're definitely going to have a bunch of bugs. And then we can do the same for the on beep. So on beep plus equal audio manager dot instance dot beep grenade underscore on beep. There we go. Duplicate that, slide it down, and change that to a minus sign. And there you go. You know what? To be honest with you, I don't actually love this approach as well. It works actually relatively well, but just kind of to tickle your whistle a little bit and put it in the back of your brain. If you were to actually want to do this with some sort of mediator pattern, that might actually be the subjectively correct way to architect this. You would have basically some sort of class in between all of your different events and in between the audio manager, and it would basically be like a mediator pattern God class sort of thing where it just listens for all of those events and handles that sort of logic that we're running into directly inside of that class. But for now, I'm pretty satisfied with how we have this set up. Let's head back into Unity and give it one more try. Alright, I'm gonna exit my grenade prefab. Don't think we need that anymore. Let's see if I can blow up my game view. Fingers crossed we have everything working correctly. So hit play. Nice. Exploding correctly. Let's see if we can get it to beep correctly. I heard one beep. I gotta stop hitting slimes. Alright. Beep. Nice. I can hear each individual beep, and each individual instance of this audio is actually being separated from each individual other grenade. So I've got each other individual grenade action working separately. All right, that was a ton of work. Give yourself a nice hearty pat on the back if you took that challenge to heart. For now, I'm pretty satisfied to move on. Well done on this lecture, and when you're ready to move forward, I will see you on the next one.